In this exercise, we showed that the limit of the square root of n plus 1 minus the square root of n is 0. We do so by showing that this expression is less than or equal to a much simpler expression. And when we do that, we're going to place an upper bound on the limit. So in order to simplify this, we're going to multiply by its conjugate over its conjugate. When you multiply by the conjugate, using the FOIL method, the outer and inner terms cancel, leaving us with the square root of n plus 1 times the square root of n plus 1 minus the square root of n times the square root of n. And that gives us this expression. Now here, the n's are going to cancel, leaving us with 1 over the square root of n plus 1 plus the square root of n. Now we know for all n, since the square root of n plus 1 is larger than the square root of n, this expression will be smaller than this one. Consolidating the denominator, we have 1 divided by 2 times the square root of n, which equals 1/2 times the square root of 1 over n. Now we know from a prior result that the limit of 1 over n is 0. Then referring to example 426 in the text, the limit of the square root of a function equals the square root of the limit of the function. So we know that the limit of the square root of 1 over n is 0. Now we refer to a theorem and its corollary. Theorem 424 states that if the first function is less than or equal to the second function for all n, then the limit of the first function is less than or equal to the limit of the second function. So here's our simplified function. We know that for all n, the square root of n plus 1 minus the square root of n is less than or equal to that function. So here's an upper bound on that limit. Now, corollary 425 states that if our function in question is greater than 0 for all n, then the limit is greater than or equal to 0. Now we know that the square root of n plus 1 is greater than the square root of n, so this has to be positive for all the terms. Therefore, we have created an upper bound and a lower bound for the limit. Both the upper bound and the lower bound are 0, therefore the limit of the square root of n plus 1 minus the square root of n equals 0.